Finding domains may be tricky when you first learn this concept. Your instructor may put on the test functions that have fractions in it, higher power of x, square root, cube root, absolute value, or some combination of them. Your test question may also have multiple terms. So how do you deal with these functions or these questions? In this video, we will look at 6 examples. But before we start, I just want to clarify that the math question may ask you to find domain or find domain restriction, but they are actually the same question. So just in case on the test, if you see a question that asks for domain and then maybe 2-3 pages down, you see another question asking for domain restriction, they're asking the same thing. If you find yourself forgetting everything from this video, remember at least one thing: what finding domain really means. Oftentimes I see students who tackle this problem, they go into the motion of repeating the steps of what they saw in the class lesson, writing a lot of stuff, making effort to make the answer to look like what was written by the teacher, just to get the answer completely wrong. So how does that happen? Well, simply put, they didn't answer the question. They answered some other question. So before we get into the example problems, keep in mind this one thing: the true purpose and the basic question behind all finding domain questions. Basically, you are asked to find all the x values that will work versus all the x values that will not work. Now, what I mean by work or not work is that x values will work if you plug in the value into the function and it spits out another number. It generates a new output, the actual number. Meaning this function, it works, it generates. However, if you plug in an x value that doesn't produce another number, or there's not a possible output, or if you get undefinedness, or if you get an error on the calculator, if you bring the calculator, then basically that x value doesn't work. So don't forget, finding domain is asking what x values will work versus what x values will not work for the function. In this first example, the problem is a rational function, meaning it's a fraction made up of polynomials. Let's go back to the basic question. Are there some x values that will make this function not work, that will make it undefined or cause an error on the calculator? Yes, if you plug in 3 into x, it would make the denominator equal 0, which would then cause this fraction to be undefined. Okay, now this is an easy problem on domain. And sometimes you cannot see right away what would cause a problem or function to not work. So let's redo this problem one more time, but we do it the proper way. Okay, so here's our take 2. We take this function, this rational function, that has a constant on top, a linear part on the bottom here, and again, we need the bottom not equal to 0, because that's what causes undefinedness. So basically, we need x minus 3 not equal to 0. So when you solve for that, isolating x, that is, you have x does not equal to 3. So what is the final answer for domain? Well, we just say that the domain is a set of all x values from negative infinity to positive infinity, but we skip over 3. Or if you want to say the shorter way, you just say x does not equal to 3. It can be everything else. Okay, let's do the second problem, but let's do it the proper way. Okay, no shortcuts. Alright, so again, we have a rational function, a constant over a quadratic, and this time the bottom is x squared minus 4. So using the same logic from before, we need the bottom part, that is the x squared minus 4, to not equal to 0. So how do you solve for that? Well, again, you want to isolate your x on one side, which in this case we're going to leave it isolated on the left side. So move the 4 over, and now you got x squared not equal to 4, and when you take the square root of both sides, x does not equal to positive or negative 2. Remember, whenever you take square root, there's always a positive and negative components to it. So there is our answer there. So the final answer for domain is x can be any numbers except for positive 2 and for negative 2. It can be everything else, from negative infinity to positive infinity. Again, this is the short way to write it. X cannot equal to positive and negative 2. And this is, I guess, the proper way to write it using set theory. Okay, and let's check our answer. If you plug in positive 2 to the function at the top of the screen here, you get 0 on the bottom, and 5 over 0 will be undefined. So remember, anything that caused undefinedness would not be part of your domain. And the same thing when you plug in negative 2. Negative 2 times negative 2 minus 4 would be 0. So both cases will cause undefinedness. So both numbers are not part of your domain. Remember, anything that causes undefinedness or error on the calculator is not part. Okay, so in this third example, we have a square root function. Okay, so we go back to the fundamental question. Is there some x value you can plug in here that will cause an error or undefinedness? Well, if you think back, you can't take the square root of negative numbers. So this 3x plus 6, whatever it is, or whatever it end up to be, it must never be negative. So what do you need here? So what do we need? We need the radicand, which is basically the stuff underneath the radical symbol. It's called radicand. We need radicand to be non-negative. Okay, so how do you write that mathematically? How do you write something non-negative in the inequality format? We need 3x plus 6 to be greater than or equal to 0, since you can take the square root of 0, so we do want to include 0. And when you solve for this expression, isolating x, x is greater than or equal to negative 2. So final answer, the domain of this function f is all the real numbers that's greater than or equal to negative 2. Anything less than negative 2 will not work. So if you plug in, let's say, negative 5, that's less than that. Negative 5 times 3 is negative 15, plus 6 is negative 9, and you know you can't take the square root of negative 9. So just a quick check there. You can always check your answer by plugging in either stuff that's part of your solution or stuff that's not part of your solution as a way to check of what works versus what doesn't work. Okay, so this fourth example, we have an absolute value function, okay, which is indicated by 2 vertical bars here with stuff in between. So how does that complicate things? How do you find the domain with these questions? Well, we still go back to the basic question. Are there any x values you can plug in that will not give you a number back? So look at this. On the very top here, you got 2x minus 5, and then you take the absolute value. It says some value you can plug in, and you don't get a value back. And the answer is no. You plug in 5, and you get 5 as your answer. You plug in 0, you get 5 as your answer. If you plug in any other numbers, even fraction numbers, you will still get a number back every single time. So the domain for this problem, we expect to be all real numbers. Okay, moving on to our fifth problem. F of x is, this time, a cube root function with the radicand equals 6x minus 7. So how do you approach this problem? Again, same way. You ask yourself, are there any x values that will cause an undefinedness? Well, to answer that question, we got to first think about what cube root really does. What kind of stuff can you plug underneath the cube root? Can you take the cube root of positive numbers? Can you take the cube root of negative numbers? Can you take the cube root of 0? So if you can take the cube root of all three groups of numbers, then that basically makes up the whole real number line. So in this case, since you can take the cube root of positive numbers, negative numbers, and 0, the answer here would be domain is all real numbers. Okay, moving on to our last example. And I want to make sure it's a combination of, two of the two, 5 previously described functions. So here you have a linear on top, but on the bottom Instead of having another polynomial, you have a square root function. Okay, so how does this problem change? Well, still going back to the basic question. You ask yourself, what will work? What will not work? What do you have to watch out for? What will cause undefinedness? Well, look on the top. If the top equals 0, would that cause a problem? No, you can have a 0 in the fraction on the top anyways. So the only place you have to watch out for something that will cause undefinedness is if you have 0 on the bottom. Okay, again, I want to point out it's very important that you don't talk about what caused the top to equal 0. That's a very common mistake I noticed on a lot of quizzes and tests in the past. Students love to solve this top part and say x cannot equal to 3/4. Well, yes, 3/4 cause the top equals 0, but it does not cause undefinedness. Again, you can have 0 on top. 0 over 5 is still 0. It's defined to be 0. It's not undefined. Okay, so if we focus on the bottom, we think back to one of the examples we did earlier, the third example. We need the radicand, which is the 2x minus 5 part, to be greater than or equal to 0. Okay, just like problem 4 again. But wait a minute, that's not it. That's not correct. Think back. There's something else we got to watch out for. We also need the bottom cannot equal to 0. So we have to amend the greater than or equal to strictly greater than. So we need 2x minus 5 to be greater than 0. And then when you solve for x here, x is greater than 5/2. Okay, and this is another common mistake. Students oftentimes like to say x is greater than or equal to 5/2. They forgot that you can't have 0 on the bottom, so you have to discard that one single point that also caused undefinedness. Okay, so we did 6 examples here. Hopefully you got something out of this. And what I recommend is maybe take 2 or 3 more of these examples and compose a new problem, and then practice with that new problem. Right? That you want to work your way up to something even more complicated, so that when you take your quiz or test, you won't be surprised. Right? The more examples you see, the less likely you'll be surprised on quiz day. Good luck.